Recording in progress.
3. Oh yeah, and video. Wait, what did you say?
Oh, you're right.
Is everyone finished?
Then you go.
You're done. Good, just check in with your neighbor, make sure that they're doing okay here.
Yeah.
It's not.
Well, that would be okay, 10 to the next.
Yeah, it's beginning.
Yeah, 80 kind of.
About 10 more seconds. Okay, ready or not? I'd like to hear about this from the one and only. Welcome back, Haley.
I just realized I did it wrong.
Oh, well, what, can you tell us at least how to start this? Okay,
And then draw the.
those are frozen, thank you. We draw the zeros, which are. Do you like that I gave them to you in order? Alright,
And then based off that, you can like see if it's like negative or positive and you find a number and then like follow it. It's like you, or not even out, but it's like the expression.
multiplicity or something? Okay.
Balances.
So how many numbers should we plug in here? Oh, do we have to plug in any numbers? Show me what we know, and that makes it so we don't have to plug in anything. Show me what we know such that you don't have to plug in anything. I'm seeing this, is that right? Or is it this? Is it this? Right, I'm talking about end behavior. Okay, so I think I'm seeing this. Is this what I'm seeing? For end behavior? Okay, so at that -4, we're gonna come down to it and I'll just say touch it, but yeah, bounce it. Okay, and then it goes up. How far does it go up?
48.
We have no idea how high it goes up, but we know that it comes back down and hits the, what does it do with that one? Are you sure it goes right through it?
Yeah.
Oh, so you graph this on your graphing calculator? No, we already know. Okay, and then of course it's gonna come back up and go right through the 3. Yeah, okay, kind of like that? Okay. And Haley, could you just give us the solution from here? Is this enough information to get the solution?
Yeah.
Okay. But of course not including negative. Do we agree?
One is you already. Wait, why the negative?
Oh, is that I don't know where that negative. Just pretend it never happened. Yes. Yeah. Yeah, what are the curly brackets? What do those mean? Simran. If it's an individual value. So the interval is if you have infinitely many solutions on an interval. But yeah, so for single values, I want it in there. If there's 2 of them, if you could do something like this, if this is another one, if we had it's touching 7 together, I would say something like that. But this has nothing to do with that.
Wait, you also just do it now.
You could put all the individuals together in one, right? If you really like doing the curly braces, you could do something like that. It says the same. If there were one answers, of course. Do we have to use a graph?
I'd say kind of.
Just think about it. I think a number line is really helpful. But we could also just do the -4, the 1, the 3, and then just determine whether the graph is positive or negative, right? So you know that these are positive here because it's coming from up there. And you know that it switches through to become negative, yes? Oh, sorry, positive. Thank you. So finish drawing that because of the multiplicity of 2. And then I think negative and negative, something like that. But I think the graph is a nice visualization, don't you think? Oh, thanks, man. It loves you too. So before I move on to today's curriculum, I want you to discuss the following. Why does it bounce with our multiplicities of 2, or why does it just touch it and not cross with our multiplicity of 2 or 4, any even value? Please discuss with your neighbor.
That's thinking, this is. That's. I think it counts on play. There's a one more time. No, but I don't really.
10 more seconds. You gotta finish up your conversation. Okay, so what's your insight? Yes, Nia. Exactly. Okay. So instead of crossing to the negative realm, it kind of doubles back. Yeah. Okay. Nice. Any other insights? I think I saw Max and then Jonas. So yes.
The way I thought about it is that when you plug in values to like a like when you're squaring values, whether or not they're negative or positive, they always end up being positive. So because of that, the graph will look like them both going like the same kind of way, but just different areas. Okay. And they all like kind of converge in one area. So like if you have like a negative in front of it, they like flip, but they're like still like kind of bounce off. So
okay, I see what you're saying. Hey Josie, do you want to answer to that or that's the same kind of thing?
Sorry, positive exponents, all the answers will be positive. You can see that with parabolas, that's up, and a parabola is more of anything that's still is the same parabola.
Yeah, perfect. But it seems like you guys are hitting on exactly what I'm looking for. Would it like to get 0, there are only 3 numbers, aren't there? And that's what we marked first, and those separate this into different regions. Those regions are either going to be positive or negative. So just what's happening with that square is any number near that -4 doesn't change signs when it passes -4. What do you think about that thought? Yeah. Like if we're going to plug in a -5 or a -3, I hope it makes sense that either way it's going to be positive. It's not going to be sign change there as opposed to this one. Where if I plug in a 0 or a 2 into this, it's a sign change, isn't it? And then here, even though this will produce a negative number, the 2 positive numbers, why is it negative down here? That's just the way it works out. If I plug in a 2 or a 4, there is no sign change. There is no sign change. That's why it just touches and it comes back. Touches and comes back. If it started above, it stays above. It started below, that means it's going to stay below. So keep that in mind as we talk about today's topic. I think finish section 8.10. And tonight's homework is from the packet, so you're gonna have to look at that online. Packet. Yeah, 3.10. 3.10 part 2. That's where you're gonna take access. You're not doing that right now because we have a lesson to tell. You guys are doing great. Okay, example 1, the graph of f is defined for -2 pi to 2 pi
inclusive as shown. What are all the values of x for which f of x is less than or equal to 0? I'll give you a minute to think about that, and when you have an answer, discuss with your neighbor.
Exact same answer.
Get it? Can I call? Shit. What'd you get? Is it negative pi to 0 inclusive? Okay, and what? Pi to pi. Are you good with this? Any questions? One of the students in my last class pointed out there is just a little bit more, isn't there? When x equals x equals negative 2 pi. There's one right there's that sneaks up on us there. I'll put that in the beginning just to keep this all in order.
That's so
ST. What's that? Right, it's sneaky. Like we're looking for the intervals, and then there's that one. Hey, don't forget about me. Okay.
Wait, there's
Yeah.
oh wait, that I was on.
You may have been.
So we're going to do another type of inequality. What are the values of theta between 0 and 2 pi for which sine of theta is greater than or equal to root 2 over 2? I'll give you a moment to think about this.
Wait, no. It's pi over coordinate. Well, coordinate y. There's not one space.
So are you all looking at this right now to solve this one? Is that what's going on? Do you agree that this would be a terrible way to solve this problem using this?
So
You could probably do it this way, but this is actually really nice because we'd like to explain why this is really nice. Just all of it.
but it's like vertical, so you want higher. So it's not for y.
Or why do you say vertical?
Just because it sounds good to y out. And we also need cross.
So we're kind of zeroing in on these, right? Okay, and that's why the answer, already have an answer? Pi over 4 to 3 pi over 4. Do we agree with that? And I hope that you all see that, and it's even highlighted there to show you the region. And I love what you said that it's higher than those 2 points that we have, and that's all we have to look at for that one. Yes. Okay, moving on. Oh, I'll give you a chance to do example 3. Having a hard time getting started. Should have typed it next to you.
I got. Wait, no, it's
You know a bit more time? Yeah, 15 seconds.
wait. Yeah.
A little bit more time. It seems like there's some good discussion. You're looking great. Oh, thank you.
Oh, wait.
Okay, so ready or not, Destiny is calling upon the one and only Simran. Can you help us out with this, please?
Verify the fact, we set a fact. We had 4 plus 2 cosine x.
Okay.
is Less than 30.
Okay.
And then we subtracted 4.
Okay, let's do 2 steps in one. Cosine of x is less than -1/2. Okay.
Okay. Even though it's in your brain. So it's that, but right. Okay. So right there. Okay. Okay. Oh. Do we agree? Any questions? Sit down, Simran.
Do the next one, please.
It feels appropriate. This is the best stuff.
I got it. This really brought it up.
We'll see what this says.
Okay. Oh, yes. Yeah.
Okay, that makes sense. It's the basic. And then the twist, if you're the cosine. 10 seconds. Okay, folks. Destiny has spoken. Max, this is gonna be cruel. It's not you. I'm sorry. But it's Kayla. Yeah. So Kayla, I started this for you. I hope you don't mind. Can you continue? Okay. Only the right side?
Um,
Okay, okay.
um, well, not using, you should be,
Okay, five or six, so right here, you're saying that here we have root 3/2, comma, 1/2, so pi over 6 to what? To what? To 0? Generally, we do in order, so if you're gonna do 0, we should be saying 0 to pi over 6, okay. And is that it? And why are you choosing that region there? What's that? Like, why aren't you going above? Like, why aren't you going like greater than pi over 6? Why are you saying it's less than pi over 6? Yeah, we're talking about cosine here, right? So we want those x values to be greater. Okay, are we done? Are we good with this? Okay, yeah, Max, what's your question?
We also go from 0 to -5/0.
Oh. Yeah, there are some values here, aren't there? So is 0 to -5/6?
You can't make it.
Yeah, Jonas?
You can't have -5/6 because it's not an interval, so you would say 11 pi over 6 2 pi. Pi over 6 union 11 pi over 6 2 pi, 0 and 2 pi over 6.
There we go. Exclusive, right? So,
No,
oh, it's inclusive?
0 and 2 pi.
Well, we're looking for when h of x is greater than k of x, not when it's greater than or equal to.
Oh.
So it would be exclusive and 11 pi over 6 to 2 pi?
Yeah.
So that gives us all of this, doesn't it? Except, of course, right here. Yeah, Simran.
She subtracted the 2 cosine x minus whatever was on there. Wait, can you just subtract cosine?
Thank you. Is it okay to subtract cosine of x?
Yes.
Is it?
You can subtract cosine of x, but you cannot divide by cosine of x. So we have 3 cosine of x on one side, 1 cosine of x on the other. When you subtract, it's left with 2 cosine of x. It has to be the same variable form. A variable expression.
Yeah.
Oh yeah, factoring should work too, but yes, Haley?
Why would 2 pi 0 be increased? Like, isn't that at like those at 2 pi
Oh.
1?
Oh, thank you. Yeah, should include 2 pi and should include 0. The question is just asking for when is cosine of x greater than root 3/2? I think 0's got to be included, doesn't it? And 2 pi, yeah. Oh. Yeah. Well, what's the cosine of 0? Isn't that greater than root 3/2?
Yeah.
So if we have to look in this to see what we could include for the endpoints, and since that one.
Would you put inclusive or both? It's not like for computing the same number or no?
It's looking for all solutions from 0 to 2 pi, so that would be appropriate. But you're right, it's a little redundant there, isn't it? A little uncomfortable with that, but it's okay. I'm gonna let that go. Good catch.
Wow.
Everything. Yeah, look at everything. Yes, Augie, it is.
Oh, so, we ended up getting here, but I'm just curious for like the first one, example 3.
Uh-huh.
Can you also represent it in like that, instead of like putting the, where it's like excluded,
Mhm.
you would put like 0 inclusive 2 pi over 3, union 4 pi over 3 to 2 pi?
Well, we're looking for where cosine of x is less than g of x, which means we're looking in this region here. We need those values over there.
That's not like.
Yeah, because these are x values that we're talking about. So we had to go. Yeah, it had to be here.
So, the values that. Okay, yeah, no.
It's all the angles that make those.
Opposite, not.
Yes, yes. Okay. You ready for the next level? You don't want to buckle up for this. Here we go. We're going to solve example 5 together. Step 1 is to. I don't think I can isolate anything. I could substitute. I'm not going to in this case because it's only a binomial, so I'm going to factor out a sine theta. Which leaves us with 2 sine theta plus 1 is less than 0. And now we're going to do this problem exactly like we did the warm-up. Right, I'm going to figure out where the zeros are for this one. I'll set this equal to 0. And 2 sine of theta plus 1 equals 0. So I'm going to do a little bit of work on the side. And here I get theta is equal to, bless you, that. And the other one, sine of theta equals negative 1/2. Here theta is equal to. Now don't write too big here, by the way. I'm sorry I didn't tell you earlier. Is this easy to solve? 2 pi over, wait, is 2 pi over 3? 7 pi over 6? 7 pi over 6 and 11 pi over 6. And what are we going to do these 5 values? Yes, we are. Oh, you're studying ahead. We are doing these the same way. So 0 pi, 2 pi, 7 pi over 6, 11 pi over 6. I just wonder who's going to copy blindly.
Why is 2 pi?
Right, this should get you very angry. Yeah, this is not good at all. It would always keep your stuff in order, right? So maybe I'll put the pi here and the 2 pi here. And this is not actually a interval there, but that makes more sense, doesn't it? Okay. We are at peace now. We could breathe a little bit easier. Okay, now do we know the end behavior of this? It's not a polynomial. I'm not sure it has end behavior. So it's periodic actually. So like end behavior switches depending on where you end. So that we just had to figure out positive versus negative. Yeah, so from 0 to pi, how do you know it's positive? Are we good with that? If you plug in anything into here, well, this will be positive, won't it? It's not be positive. And this will also be positive, won't it? No matter what we plug in. And you're plugging in some positive numbers, doubling it, and I'm adding 1. It's super positive from 0 to pi. Yes, Chloe? Yes, exactly. And when I plug in a pi, the y by that comes out is 0. Thank you for helping me make that clear. Does that make sense? I'm talking about the output.
Yeah.
So we're putting in numbers here in between 0 and pi because I know there are no zeros happening in there. And all of that's just going to be positive.
The sign of the inequality sign. Why do you say them before?
Well, same thing with the warm-up. Remember it was just less than or equal to 0 or something?
Find the zero.
Yeah, you find the zeros, you set it equal to 0, and then ignore that for the rest of it. We found the zeros there to find our regions. Now, should I find 1, 2, 3, 4 more? Oh, well, 1, 2, 3 test points. Should I test 3 more?
No.
We want to see if it's crossing or touching. So in order to do that, what I'm going to do is I'm going to make 2 little graphs. Y equals sine of x and y equals 2 sine of x plus 1. Now y equals sine of x is super simple. It better be super simple. You have your pocket signs, I know that. Okay, yeah. Yeah, we're ready at a moment's notice. Can you please make a quick graph of 2 sine x plus 1? And check with your neighbor once you finish that. It's a quick little step. It's the area, put it right up. I like that I'm hearing amplitude. I like that. That's good. 2 thumbs up from me. Yeah, before graphing, you're probably gonna put the midline. Doesn't that help to graph the midline, which is y equals 1, so it's up here. Just a really quick sketch. I'm not gonna try to be too specific. And then I also have to consider the amplitude. So from that 1, we're gonna go up to 3, go up 2 to 3, right? We're here, we're 1, and then go all the way down to -1. So to graph this, right, just a quick sketch. Are we comfortable with that? Do you see what happens in this sketch? It's stretched, vertical stretched by a factor of 2. I also want you to notice that it crosses that axis. You know what these 2 values are right here? Yeah, we know what these are. This one is 7 pi over 6, and this one is 11 pi over 6. So when I'm continuing my analysis, I'm gonna give you a moment to catch up with your sketches. Okay, and I'm gonna ask you, even if you didn't finish your sketch, go ahead and put your pencils down just for a moment. I just need to see if it's changing sign at pi. Now, the 0 that pi came from was sine of x, isn't it? It changes sign, which means, don't write anything down yet. I'm just gonna do this. All right, here at pi, nothing interesting is happening. It's going from positive to positive. Nothing interesting is happening, right? But for sine of x, the sign is changing, which is why it goes from positive to negative. 7 pi over 6. We look at the second sketch and say, hey, it's 7 pi over 6. The signs, S-I-G-N, is changing, which is why we're going to go from negative to positive. How about 11 pi over 6? Are we sure it changes?
Yeah.
Yeah, right here it tells us 11 pi over 6 that the inputs go from yielding a negative to a positive, which means ultimately it's going to result in a sine S-I-G-N switch to negative. I'll give you a moment to catch up, discuss what I just talked about.
It's the reason why it doesn't like map directly to that is because of the second graph, which means that it'll be like double negative and positive.
Exactly, yeah. Our functions are being multiplied by one another.
So that way, the only reliable way is just to figure out what it is.
You look at that.
Oh, pi.
Oh, how are those easier?
Yeah.
I think we were wondering this question.
Uh-huh.
Why are 7 pi over 6 not having to be that? It's gonna be a positive. Not the one on the left. Oh.
If you look up from solving each piece.
So just
Oh.
graph.
Yeah, it depends on the graph. The factors of the,
Pi, 2 pi.
Haley, and then Lee.
Like positive to positive and negative to negative.
Oh, that's a great question. Thinking 2 steps ahead. We'll see in the next one. Yeah, Lee.
Wait, so. Did I tell I would say I would say that we signed the rest of the that take it that way positive with this sign those 2 pi.
Good point. We have to keep in mind that we're multiplying one factor by another one. So those little negatives that you see over there are being multiplied by the negatives over here, which I think result in a positive. We don't need to think about all that, but all you have to think about is the sign S-I-G-N for this. Is it changing? Is it not changing? And Haley asked a great question. Is there ever a case where it's just not changing with sine or cosine? Let's see. And if you still have questions, I'm going to hold them off until this next one, because I think that this will illustrate but some of the ideas. Step one is, can you factor that guy?
No, you can do something.
I don't know.
We know how to do this. We know how to do this.
Okay, to factor this, 2 cosine squared factors into cosine theta times cosine theta. Do you have that? And if you did a substitution, that's fine. 1 factors into 1 and 1. And where does the plus go? It goes on the right. This one's minus, and it's still greater than or equal to 0. So from here we have cosine of theta is equal to, I'll do this on the side like I did last time. Cosine theta equals 1/2, just finding the zeros. And cosine of theta equals -1. Are we okay up to that?
Yeah.
Okay, so I have on my, I need to figure out theta. Theta equals, the second one, you're right. Theta equals pi, right? We know from the date. And the first one, theta is equal to pi over 3 and 5 pi over 3. Shout out unit circle. So in order, the first one is pi over 3. Then pi. I'm just going from 0 to 2 pi. There are more solutions, of course, but I just care about the ones, not in a heartless way. I just care about the ones from 0 to 2 pi. Can you make a little sketch of both of those functions? Y equals cosine theta, and I'm sorry, no, it's y equals 2 cosine theta minus 1, isn't it? And y equals cosine of theta plus 1. That's just, those are the 2 factors. What happens with that second graph? It's up 1. So it looks something like this, doesn't it? Does that make sense for the second one? Where this is 1 right here, this is a 2. So when we do our graph now, we have to think, add pi over 3. Do you see pi over 3 from our mini graphs? There's a pi over 3 right here, isn't there? Well, they're multiplied by one another, so we can't look at only one, but we were looking at the behavior. Yes, we are gonna check each one independently. That other zero is, of course. I'm sorry, it's not, yeah, it is pi over 3. This is 5 pi over 3, isn't it? And this right here is pi, those x values, the inputs. Yes?
Yeah.
So what we need is a starting place. I'm gonna start left to right. What number should I plug in? Less than pi over 3?
So
Zero.
it's gonna be.
0. That's why I couldn't plug in a 0 because 0 was a 0. So here when I plug in a 0 into my either my original function, original function. Cosine of 0 is 1. 1, you square that. 1 times 2 plus 1. So we have 3 minus 1 is greater than 0. It is positive there. Yeah, Haley? It's actually a really good idea to plug it into the factor version. If we plug it here, we plug in our 0, here we have 2 minus 1, and here we have 2, so 1 times 2, positive. What's gonna happen to pi over 3? Are you sure it changes sign?
No.
Yeah, the graph shows us right here. It shows it quite clearly. Right here, it's gonna change sign at pi over 3. So that means my positive will go to negative. It changed sign. At pi, you're on pi from here. Where the values go from positive to positive. So that means that there is no sign change. Here it's going to be negative and then negative again, which is exactly what Haley was asking about. So that's what it would look like here. So it's not like the parabola we were seeing with the polynomials. It's the cosine comes down and just like touches that x-axis. Yeah, Nathan?
That, the second graph for y is cosine beta plus 1.
Uh-huh.
That graph from to Alfonso thing, like when we're fighting, like it's positive, negative, like it doesn't really matter.
Oh, that's nice. So since the second one's always positive, we just really only have to look at this first one, don't we?
Yeah.
Does that make sense? The only thing we care about in there is the zero. And what we're saying? Yeah, so yeah, and that's determined by that. But oh, that's really nice insight. Nathan, I'm sorry I didn't get that earlier. I see what you're saying. Yeah, the graph was like fully negative. It would be the same. Yeah, just wouldn't change signs. And lastly, after that 5 pi over 3, which we see happening right here, and we see very clearly that there is a sign change, which is why it's going to go from negative to positive. So the answer to our question. Which values is that function greater than 0? Not negative 3, because this isn't a polynomial. Yeah, over. 0 to pi. Or he's talking to 2 pi. Exactly. It's just asking in that window from 0 to 2 pi. And is this all inclusive?
Yeah.
Yeah, all inclusive. Okay, so that was a lot. Did the second one, the contrast of the second one help with the first one at all? A little bit. Well, I have this. I'll put it up on YouTube if you want to watch it. We don't have time for questions right now because I have some questions for you. Can you do the questions on this quiz? Just the one in your brain. Did you charge it? Oh, yes. Oh, does anyone have one he could borrow? You're already late.
Oh, I'm getting rid of it.
Oh, everything off your desk. However,
I don't know. I know.